Hannah, NHCSR. It is winter time and we are planning our field trials. I want to see if I can create a party zone for pest insects using attractive odors, attractive plants, a combination of the two. So this party zone is a place where we want pests to aggregate for a few different reasons. It will divert their movement into the cash crop that you're trying to protect, so it'll intercept that, stop them in their place. We can also use this place to monitor for those insects, to make some other choices, or we could control that pest population there in the party zone using chemical controls or other means. As I'm thinking through the details of this trial, I am trying to nail down the exact lures I would like to use. There are commercially available lures that contain a blend of compounds, a blend of chemicals that are found in floral odors. So I know that floral odors are attractive to my target pests in this study, tarnished plant bug, and to a lesser extent, striped and spotted cucumber beetle. Now these are cheap and easy to buy online. I know that they are attractive to my target pests. However, floral odors are also attractive to other non-target insects that we care about, the pollinators that are also living in these agroecosystems. And if we are using these party zones for chemical control, that could complicate things. So I was very excited to see this paper come out, hot off the presses. It's a real page turner, so I wanted to share a summary of what this team learned. And as a side note, this paper does acknowledge funding from the Crop Protection and Pest Management Program, funded by the USDA's National Institute of Food and Ag, and it provides funding for integrated pest management research in every state. So if you think about your local extension agent who has advice on how to deal with pests, they are being paid and sent to your farm because of Crop Protection and Pest Management Program. This program also funds a little bit of research, just like the research that we're going to cover today. And this program was nearly axed about a year ago, which was really surprising considering how much the program does, how it touches every state, especially how much it does compared to the cost of this program in the grand scheme of things. It's so very excited to see that that program is still existing as long as we know. Luckily, our senators insisted that the USDA keep its budget consistent from the year before. So I know there's not a lot of good news out there right now and no love lost for some of our senators, but there's one good thing. And this project is a really good illustration of how researchers from multiple institutions will pool all their resources, put their heads together, and really make the most of those resources for the good of the goal at hand, which is to develop a tool that is actually useful for farmers while minimizing non-target effects. That is kind of the name of the game when you're talking about integrated pest management. All these experiments were replicated in Indiana, Maryland, Virginia, and out in California, where they have a related western species of some of the beetles that we're talking about on the East Coast. I am just going to focus on East Coast species for now, but there's a lot of patterns that are similar. So this study aimed to identify a pollinator-friendly lure for cucumber beetles, which is a pest of cucurbit crops. They do some indirect damage by feeding on the leaves. Sometimes they'll do direct damage by feeding on fruits like melons. It can really reduce the crop quality of melons. And they also are vectors of a couple of plant diseases. So they are looking to manipulate the behavior of these pests by evaluating the response to 3 lures. Cucurbit floral mimic, TIC, so 3 compounds. One of those compounds on its own, Indole, and the aggregation pheromone beta-lactone. So this is a synthetic version of an aggregation pheromone from one species, but we'll see that a lot of the species that we are looking at will also respond positively to this aggregation pheromone. It's really cool. Okay, so these graphs show the total number of striped cucumber beetles per trap. They were putting a lure next to a sticky trap. So in theory, any beetle that came close to it would blunder into this clear sticky trap and be captured. On one side of the graph, you have traps that had the pheromone beta-lactone, and on the left side, there's traps without the pheromone, and then that's layered on whether or not it was blank, no floral lure, or one of the 2 floral lures that we're talking about Indole is that singular odor, and TIC is the three components that include Indole, the I's for Indole. Striped cucumber beetle. This is the specialist feeder on cucurbits specifically. They were strongly and consistently attracted to beta-lactone. That makes sense. It's a synthetic analog of its aggregation pheromone. Its response to the floral odors was a little bit inconsistent across the different regions, but we still see some responses. On the other hand, the Diabrotica species, those are the spotted cucumber beetles, they showed a much stronger attraction to the floral odors than beta-lactone. This kind of makes sense too. Like they are cueing in beta-lactone, they're probably eavesdropping on what the striped cucumber beetles are doing, but it makes more sense for them to cue into the floral odors. Nonetheless, they found synergistic effects when they combined the aggregation pheromone with either Indole or TIC. So the aggregation pheromone combined with that one odor on its own or three odors together resulted in the highest pest trap catches. So that's pretty cool because that means that they got the same response with the single component Indole. And why that's important. TIC, the three odor component, was attractive to pollinators. We see the floral mimic, the TIC, strongly attracted to honeybees here. And then again, wild bees, and they were looking at a couple of species of ground nesting wild bees. Up to 73% more bees attracted to that three component floral lure. Neither Indole or beta-lactone attracted pollinators. In some cases, wild bees, it looks like they were actually repelled by Indole. So we can see where that would be a really powerful tool. Going forward, they're definitely looking at developing a lure that combines Indole and beta-lactone in a commercial lure. I think they are working with commercial producers to do this. That is a benefit because it's not attracted to pollinators, and Indole happens to be a lot cheaper to produce than beta-lactone. This is a very specific chemistry, so we can see that they are getting much closer to producing a commercially viable product for people who are trying to manipulate these cucumber beetles. My next step is to see if all of this holds true with tarnished plant bug. So we will see that out in the field this summer. I'm going to do my best to see if I can get a hold of the same lures they used in their study. I have written a few emails to see if I can do that. One of them is commercially available, but the other one is not. So stay tuned, and thanks for listening.